Now let's do a hands-on example. I have a DC brush motor with 24 volts DC rated voltage, and it can handle about 2 amps continuous and 4 amps peak. To calibrate the DAC offset, I first want to reset the encoder counter using an HMZ command. For motor 1, this will be #1 HMZ. You can see here in the position window that the position for motor 1 has been reset to 0. This makes observing changes in position much easier because you can compare them relative to 0 rather than some arbitrary position. Now I want to issue an Out20 command and observe in which direction the motor moves, whether positive or negative. For motor 1, this command is #1 Out0. Then I issue a K command to kill the motor. I observe in the position window that the motor has run in the negative direction. This means I need to increase motor X.DAC bias in the positive direction. On my system, I'm using an Accessory 24E3 access interface card, meaning that I know my output control signal will be between -10 and +10 volts DC. If I put a DAC bias of 32,767, I will be putting a DAC bias of +10 volts DC. But since this motor did not run away that quickly, I will try just adding about 1,000 counts on the DAC bias. For motor 1, the structure is motor bracket 1.DAC bias equals about 1,000. Then we want to clear the encoder counter again with an HMZ command. You see that the encoder has gone to 0. And then issue another Out0 command. And then issue a kill. We see that the motor is still running away, but not quite as quickly as before, meaning we've definitely caused an effect. In the terminal window, you can press up 4 times to get back to your previous DAC bias command, and then I'll change 1,000 to 2,000. We want to clear the encoder counter again with HMZ, issue another Out0 command, and observe the motion. The motor is still running away, but only very slightly. We'll add about 1,000 more counts on the DAC bias. Reset the encoder counter, and then issue another Out0 command. And then kill. We see that the motor only moved a little bit and then stopped due to friction. At this point, you can actually finish your DAC calibration, because it means that friction will actually overcome any DAC offset in the system, so there's no need to tune further. Once you've finished your DAC calibration, make sure that you add the final DAC bias value that you came up with into your motor setup file in your project manager of the IDE. That way the DAC bias correction can be downloaded with the rest of your project source code and stored permanently on PMAC upon issuing a save command.